So today we are gonna do question number 1195, Fizz multithreading. So it's a concurrency question, and see in this video, I'm not going to use synchronized block, locks, semaphore, or anything that blocks the thread. I am going to solve these questions with only volatile variable. With a single volatile variable, I'm going to solve this question. uh, in the solution tabs you can see no, there is no solution available that has used only volatile variable to solve this question. Even though I would say that my approach is not a optimal approach, but I would say it's a unique approach. If in interview the like interviewer say, okay, don't use uh, any locking like stuff like synchronization, semaphore, locks, cyclic variable or anything, don't use that. So in that case, this particular solution will make you stand out because it doesn't use any of them, and it's a single volatile variable that make the solution run. So, first of all, what the question is saying that yeah, that we are given a class, and in that class we are given four methods. Print fizz will print fizz, print buzz will print buzz, and print fizz buzz will print fizz buzz, and print number will print an integer to the console. Okay, that's great. Now the question further has said that an instance of his was will be passed to four different threads. Thread A will call fizzbuzz. Oh, sorry, fizz. Thread B will call buzz. Thread C will call fizzbuzz. Thread D will call number. Okay, that's great. Now, right now, everything is clear to this point. Now modify the given class to output the series itna. Okay, we have to print the series, and where the ith token of the series is like this is the ith token, and how that ith token is gonna be like what is going to be is given here. Okay, and it's one ways to, so it is start from 0 1 2 3 4 5 and so on up to n. Like Fizzbuzz, if I is divisible by 3 and 5, if it's divisible by 3 and not by 5, buzz if it's divisible by 5 but not 3, and number itself if it's like index itself if it not divisible by any of 3 and 5. So first of the thing that struck to my mind that make me think in a direction or think in a direction of using volatile and not any blocking mechanism. See, all of these four conditions are unique. All of these four conditions are mutually exclusive. Means at for a given value of I, only one thread will execute the function. It means it is for a I, only one thread is going to update I. Means only one thread is going to write I. So the problem of atomicity is with the volatile variable is solved. Okay. Uh, like Let me implement some code and will tell you what I'm trying to say. Volatile I, then will initialize I here with a 1. Now since we want to keep thread running up to our I is less than equal to n, so if I is divisible by 3, like what's the condition of Fizz divisible by 3 but not 5. Okay, and I shouldn't be divisible by 5. So you have to, like, what is it? Okay, then I plus plus, same thing, something similar to this gonna be going to be done here, here, and here. So the condition for Fizzbuzz will be that both should be divisible by 3 and 5. Sorry, I should be divisible by both. For number, it should neither be divisible by 3 nor 5. And for buzz, it should not be divisible by 3 but should be divisible by 5. So right now, any of the thread will come, it will first check the condition. Now once the condition is checked, it will loop until I is invalid. Okay, now it will check condition, and every time it will read I from the main memory. So either of the thread updated, everyone is going to read the fresh value of I, neither of them going to read stale value of I. So since all the conditions are mutually exclusive, only one thread will at a time pass this particular condition and will update I. Since only one thread at a time is updating I, the atomicity problem, that the problem with the volatile variable is that you cannot volatile cannot be trusted where or should not be used where the operation are not atomic. Since here I plus plus is not atomic, but at a time only one thread is going to update I. So atomicity problem is you can say eliminated here. Okay. So now you will be thinking that okay, it's mean the question is solved, but it's not the case. Tell you why. Okay, there is some problem. Okay, I did forget to give it a type. There is some problem here. Shit. See, the problem is not solved yet. It should be I here. Okay. There is some issue even now. What is the issue? The intervention cannot apply to your type. Is not run What the issue is here? Okay, we have not to pass arguments. No. You can see only this particular test case has got our correct answer. All other are like wrong. Why? Because this solution right now have race condition and still atomicity, but not with I. The race condition and the atomicity are with this particular if statement. Why? Let me take an example. Suppose I is equals to 3. I is equal to 3. Let T1 is Fizz. T2 is Buzz. T3 is Fizz Buzz. And T4 is number. Okay. Suppose I is 3 and I is 3, it entered to Fizz was okay. Now thread third, I at some like let's say in the value of n is 5. Okay. Now at some iteration, at some iteration I is equal to 3, the thread 3 enters, check the while condition. It says yeah, it's correct, like 3 is less than 5. Okay. Now it comes to if statement, and it execute this particular half condition 1. It execute condition 1 and it evaluates the true. Now before executing condition second, the CPU switches its context and start executing Fizz. Now it check its while condition. Let's check this particular condition. Check this particular condition. Print Fizz and increase I. Now I is equal to 4. Now I is equal to 4. Neither the CPU directly switches to this and print I is equal to now I is equal to 5. Okay, now it came to Fizz was, now execution was left over here. It execute I modulo 5 is equal to 0 and it evaluates to true, because right now I is not 3, it's now 5. This particular evaluates to true for I is equal to 3. This particular evaluates to true for I is equal to 5. Due to, since this condition, this particular expression is not atomic, we this and since not atomic, half of the expression was evaluated at I is equal to 3 and rest half was evaluated at I is equal to 5, due to which this particular expression evaluates to true and it prints Fizz was, which it shouldn't, because at 5 I is equal to 5, it's not divisible by 3. It should print the number at I is equal to so it should print buzz at I is equal to 5, but because non-atomic behavior of this of if statement, it print this and it may also print this. So you are understanding, because of the race condition and non-atomic behavior of if statement, we are getting our answer in wrong order. So first of all, those who don't know what is race condition is that if the answer or output changes as a result of change in execution order of threads, this led to race condition. Means if the answer is directly linked with the executional order of threads, then it's a race condition. Like first of all, thread A execute, B execute, C execute. Answer is something, let's say R1. Now execution order got changed. Now first of all, thread C execute, thread A execute, thread B execute. Now answer is something else. So this is a particular example of race condition. You said first this was executed, then context switched to buzz, then to number, then to again buzz. The answer was different. But if the execution order was something else, then answer may be something else. Like if it had at I is equal to 3, this thread never got CPU, then it never had evaluated I modulo 3 is equal to 0 as true. So it is a case of race condition. Why race condition? Because this expression is not atomic. So I hope you understand why race condition and non-atomic behavior is like holding our solution to be an acceptable solution. So what we can do, like how we can make it atomic, so that order in which threads are executing doesn't matter. See, that right now the problem is that we don't want the value of I to be changed while evaluating the expression, while evaluating the if statement. This is our main motto. So we want that the value of I only updates before evaluating or after we have evaluated the if statement. So what we can do is that we can take a snapshot of I. How? We will store the current value of I into current I, and instead of checking I, we will check the snapshot. Similar we will do over here as well. Similar over here, and similar over here as well. And let me copy this as well. See, right now we are getting a wrong answer in between also, like here, okay, in between. Now will you, if you think this is a correct solution, it's not yet. We are slowly moving to a correct solution, and we will surely get to a correct solution, but we need to know what are the problems that we face while getting to a correct solution. This is, at least these are the problems that I faced before getting to the correct solution, and how I think. There is some issue here. I guess this should be the issue. No, other. So there, okay, we have to comment this code. Okay. See, right now all our test cases got getting having a accepted or correct answer, but it's not the case. Let me spin it again. Then you will see there is still some error in this code. You see, we are getting extra fizz. The count up to 50 has already been done, but we are getting extra fizz over here at the end. Let me spin it again. Okay, now you see we are getting a fizz again at the end. Why? Let me spin it again. Okay, let me add more test cases so that 24, and then we add like 40, and then we add like 33. Arey. Okay, so you see, we are again getting something at the end. Why it's that? Why it's that happening? So see, there is another case. See, right now there is another scenario, but before that, right now our I is atomic. Like I problem of I, like I plus plus not being atomic has been resolved. The problem of if statement not being atomic has been resolved. Now, what's the problem that we are encountering now? Let me tell you what the problem is. See, when I is equals to 15, for example, and n is also 15. For this particular case, what should be the answer? Fizzbuzz? Fizzbuzz? So let's say you check the condition of while loop I is less than is equal to 15, and you take the snapshot. Okay, you take the snapshot and then context switches. Here this also read this and this particular thread, the thread like that's executing buzz, also check its while condition, it's evaluated true, but it doesn't take the snapshot and then context switched. It also check its if while condition, but before taking the snapshot, the context switch. It also check its while condition, enter into the block before taking snapshot, the context switch. And now we are again on the Fizz bus. Now every of them is inside the while condition, while block, sorry. Now it take the screenshot it already had. That is now current I is equal to 15. It's like 15. This evaluates to true. This evaluates to true, and it prints results. And I increased to 16. Now since now context switch to any of this like thread because uh, this particular thread is already in like stopped or dead, like terminated, because now I is 16, this particular value will evaluate to fall and then the thread will end because the function is ended. Now but these function, these thread which are executing phase bus and number are not, because they are in the while loop itself. Now they took the screenshot 16. Is 16 not divisible by 3 and 5? Yeah, it's not. It prints the number and increase I. Now it's check its condition if while condition evaluates to false and it's terminate, and then they come over here. It's like take this snapshot, evaluate this condition again, while condition false, terminate a false no, sorry, it take the snapshot, evaluates the if condition to false, then again checks the while condition, evaluates to false, then came out of the loop and finally terminate. So you see that you have noticed that what I was saying, that even after Fizzbuzz has been printed and I has become to 16, which is greater than n, since there is no check over here, that is like that should restrict the value of I, we printed number even though we shouldn't. So what the another check we should put is n. mm, okay, and now if we spin, we are guaranteed to get correct answer. Okay, we get error because we haven't commented that code, and yet some error are destined. So an I has to be appended at the end of the quadrant in order to, okay, see all our answer are correct. We spin it and we are getting a runtime of 5 milliseconds. So this was the very unique solution that I haven't seen in the solution tab. Nobody has posted a solution using volatile. See, we do not use synchronization. We are not blocking any, like we aren't blocking any thread. We are not using log. We are not using semaphores. We have solved this question with volatile only. But the problem with here is we are not blocking threads. We are continuously burning GPU. Like if our thread, if a thread is here, like when I is equals to, let's say, 9, I is equal to 9, this condition evaluates wall, then thread again call this false, thread again call this thread false, again false, again false. So if context doesn't switch at the right time, we will end up into an infernal loops burning out our CPU. So that is why this approach is not optimal and is not acceptable in any production level code. We have to use synchronization and all that stuff, so that once the condition is solved, we can wait our thread so that it stop using CPU, and other threads which are like potentially the one that need to be executed get the chance. So you understand how volatile being used here, how snapshot is being used here, and why it's not the optimal approach, but it's a unique approach. That's it.